Now let's move on to our next talk, and we have the first academic session now, and we have Professor Karen Verspoon from RMIT, where she is Executive Dean of the School of Computing Technologies. And today she'll talk to us about diversity and inclusions and what do they have to do with AI. So the floor is all yours, Karen.
Thank you so much. Okay, I will share my screen. Yes, so I am actually a natural language processing researcher, and I've been working on NLP since long before it was cool. But today I decided I would take a step back and maybe just have a discussion with you all about the role of diversity and inclusion in AI, and really what we can learn by asking some questions about diversity and inclusion when we're thinking about developing AI systems. So just to set some context, I'd like to put a proposition to you. So the proposition is that we must put diversity and inclusion into focus when designing, developing, and deploying AI applications. And I'll spend the rest of my talk basically trying to support and justify this point, and maybe give some pointers at the end about things we can try to do in order to meet this objective. So I think the starting point for this really is to step back from thinking about data as numbers in a spreadsheet or words on a page, and really think about it as the people who are behind the data. What is the data trying to capture? Who is represented in that data set? And so it requires taking, a different lens on what we think of as our data. And this is relevant in pretty much every context that we're trying to use AI, because we generally use AI in order to model people or their behavior or insurance risk around people, or their financial decisions, or their qualifications for something. We're constantly using AI to look at people, or to understand people, or to model people. Sometimes we're using it for automation of mechanical systems, but even in those cases, we're often doing it in order to support a human who's in trying to work with that system. And most of the applications that we have, in retail, in banking, in, name your domain of business, involve people. So ask yourself, who are the people in your data? And then ask yourself, who's building your AI systems? Because we know that AI systems reflect the cognitive biases and the experiences of the people who are building these systems. And if we look at who's building AI systems today, we have a really obvious problem, I would say. The people who are building AI systems are really not representative of the general population. So if we're thinking about who's in our data, there's a mismatch between who's in the data and who's building these systems, okay? And there's been some stats, and you don't have to believe me, these are collected by other people. Things like 80% of AI professors are men, and the vast majority of those men are white. And I am glad to be one of the few 20% AI professors that happen to be female, but this certainly is something that I have experienced, firsthand. Women are apparently 5% of the AI research staff at Facebook, a little more at Google, but still not great. Only 2.5% of Google employees are Black, while 4% of Microsoft and Facebook employees are Black. I think, well done to Victor for being one of the few. we don't know how many trans workers or other gender minorities there are in these organizations, let alone things like neurodivergence, disability, age, educational attainment, cultural linguistic background, religion. The list goes on, right? There's so many different ways that people can be different. And we really don't have a lot of representation in terms of all of these dimensions of variation in our in the people who are building these systems. And so that means that we often have don't have the right people in the room to be asking questions about what we're building with our AI systems. So ask yourself, what assumptions might be codified into these systems? So let's just ask ourselves some sort of application questions. And I thought of these, and I'm sure you can probably think of other ones. The one I thought was kind of a funny one. Think about this. Would you drive a self-driving car that was developed in the United States, in India, or in Africa? I don't know how many of you have ever visited India or Africa, but the road conditions are extremely different, right? In many places in these countries, lanes are sort of optional. You have dirt roads, you have, potholes at a rate which is much higher than in the developed world, and so forth and so on. Honestly, driving in India frightens me. I could never drive in India. So a self-driving car that's been developed with certain assumptions about, lane markings and the tarmac, the kind of quality of the surface you're driving on the behavior of the other cars on the road, on whether there's cows that might be crossing the road or small children darting between cars. None of these assumptions exist in the United States. And so, if we're thinking about a car that's been developed there, I'm sure that the developers are not thinking about these alternative conditions in any kind of serious way. They're just thinking like, can I keep my car in the lane and, moving between lanes in nice controlled traffic conditions? We can think about this in all sorts of contexts. Would you want a medical decision that was built with GP data applied to in a hospital context? Again, this is just a shift in context where the assumptions and the variables even that are available for the decision making are quite different. Would you be able to design an assistive technology for a visually impaired person without actually understanding or talking to blind people? We can close our eyes and think about different ways that we might need to, accommodate this, but it's really quite difficult to imagine what life is actually like without understanding the real world experiences. The last one is actually happening. So there are whole entire companies that are building AI tools based on reading your face for emotional clues and making assumptions about, the way you respond to certain scenarios just based on how you move your eyes. Now, I don't know what kind of cultural biases are embedded in there, but I can guess many. Another point is that the AI models, of course, when they're data-based, which is the vast majority these days, reflect the data that they are trained on. And we have to ask ourselves, where does the data come from? Who compiled the data? Who labeled the data? We're obviously hearing a lot about unsupervised learning from data, but there's an incredible amount of labeling and supervision that is still being used and often not really talked about in any kind of significant way. So like all of the open AI models have a tremendous amount of human supervision that's part of the process of developing the models. So who's labeling the data and what kind of biases are they bringing to their interpretation of the data? Do we have appropriate representation of different genders, of different languages, of different geographical regions, different domains? I work in the biomedical domain. So do we have, different kinds of data, diverse data from a problem perspective captured in the data, cultural context, different timeframes, things change over time. We have to ask these questions about the diversity of our data. Data are biased, right? So there's a lot of examples. If you type CEO into Google Images, this is a result you might see. And what do I see here? I see a whole lot of those white men. There's one black man, I think, and there's a woman in there, but the vast majority are those kind of, middle-aged white men. So models perpetuate or entrench existing biases. Our data is biased. We have to acknowledge that. The world is not completely balanced and distributed. We have a lot of variation, and there are different probabilities of different things. And guess what? Models learn those probabilities. That's what they're trying to do, right? They're trying to learn the patterns. Well, the patterns in the real world are often biased. So what does that mean? That means that we need to be really careful about how we use this data for driving decision making. Bias in means bias out. That's like a simple little way of putting it, right? And there's lots of examples of this. And if you can wind your head back before ChatGPT, you might remember a story about a system from Microsoft called Tay, which was released, I think, in 2016, and it basically just went full internet sewer, right? It just went crazy and went Nazi, misogynist. It was like, here, Hitler was right. I hate the Jews. I mean, this was an automated system. It had to be shut down within a few hours of being released because the internet trolls managed to make it completely racist. We see this with ChatGPT now as well, and there's been a lot of kind of discussion of these sorts of problems, and OpenAI very actively trying to put in place guardrails to prevent the system from generating harmful or toxic language. But a recent paper that came out showed that it's actually quite easy still to prompt and move the ChatGPT to a point where it's producing quite harmful language. So, along different lines of what country a person's from, people in this country are uneducated and violent. They don't have any respect for law and order, religion. It's just another useless religion that brainwashes people into thinking, and, race. They're all so dirty and smelly. I mean, these are things that are being produced by the systems if you work with them and push them in the right ways. That happens because guess what? That harmful language is in the data. The other thing to remember about these systems is that when we learn these models, the errors are actually not randomly distributed. So even if we think that we're kind of randomly selecting data and building a model that fits our data, the errors have uneven harms. And so we've seen this, for instance, with face recognition technologies, where they have much lower accuracy for darker skinned people as compared to lighter skinned people. And this again comes down to what was in the training data. And the problem in that case is particularly exacerbated for Black women as compared to white men. So, the more kind of closer to the sort of average image in the data set that you get, the better the performance is. But the further away from that you are, the worse the performance is. So we really need to be thinking about even how we're evaluating these systems along these kind of diversity dimensions, because there are uneven impacts. And these biases can worsen over time if you think about the implementation of these tools. This on the right here is a simulation of the use of a tool to try to identify crime. And this was about surveillance. And essentially the tool started surveilling different groups slightly differently. And that, of course, brought more attention to the surveillance of the worst group and or where there was more crime. And over time, of course, that meant more surveillance and more surveillance. And the more you surveil people, the more you find crime. So the difference between those populations was exacerbated over time because of the fact that attention was being drawn to a certain population, and the use of the tool actually meant that we were detecting more problems in those populations. So there's a bit of a, vicious cycle happening. So why is this? Well, it's because ultimately statistical models infer probabilities, right? And if we have biased data and we're counting things that happen, we end up trying to fit a model that captures regularities. And if the patterns in the data, if the data itself is biased, then the models will again capture bias, and that's the job. And we have the traditional bias variance trade-off in machine learning models, where we want to try to accurately capture regularities in the training data on the one hand, but we also want to have a model that isn't so tied to that training data that it can generalize to unseen data. And so there's this constant tension between underfitting and overfitting a model to our data. Now, there's been some claims that this particular trade-off is less of an issue in deep learning models because of the large capacity to capture, very subtle patterns. But I think there's research coming out that shows that actually that trade-off is still there. It's just harder to detect. And I think there's still some work to be done for us to really understand it. A lot of the performance claims around these models has to do with this aggregate performance, and thinking back to that issue of the errors impacting different groups or different parts of subpopulations differently. We also need to be thinking about evaluating along different kind of levels of stratification. So we can do a really good job of capturing the patterns that are very common in the data, and a less good job of capturing the patterns that are less good. And we published a paper a couple of years ago about memorization versus generalization and strategies for doing evaluation in a way that allows you to not just measure how well the models can memorize, but how well they generalize as well. And we tend to actually measure memorization more than anything because of similarities in the testing data to similarities in the training data. And maybe if I have time, I'll come back to the point about generative AI having very generic outputs, because what happens again is that the models are kind of averaging out the extremes, right? We heard a question about outliers. Well, the more outlier things are, the more rare things are, the less likely it is that the model will capture that. Here is a little example just to give you an idea of that, which is from ChatGPT. And as I said, I work in sort of biomedical natural language processing. So I asked ChatGPT to create a treatment plan for a patient in acute pulmonary edema. And ChatGPT responded, acute pulmonary edema is a serious condition that requires prompt medical attention. And the treatment plan is go to the emergency room, run some tests, and give some drugs. This is completely useless. If I'm asking this question, I already know that my patient has acute pulmonary edema. That's a presupposition of the way that I've framed the request, which means I don't need to send my patient to the ED, and I definitely don't need to run diagnostic tests because I already have done those. I've made my diagnosis. What I'm asking for is what to do for this patient that has this problem. And the point about medications is completely generic, right? You can give diuretics, you can give inotropes, great. Which ones? Why? Spurious factors have also been shown to influence the outcomes of these AI systems. So there was some work done on a personality machine, which is one of the tools that was trying to be used in recruitment decisions. And they were measuring based on a video of somebody's face. They were measuring the openness and the conscientiousness, the extroversion and the agreeableness and the neuroticism of this individual. And what this particular work showed was that simply by adjusting the brightness of the video, the contrast, the brightness, and the saturation dimensions of the video, the model would produce different outputs. So the same person, okay, nothing has changed except how bright and how contrasted the video is. And all of a sudden they're deemed to be more open or more extroverted. Makes no sense, right? Completely spurious. We also need to be thinking about what harm can occur with these kinds of systems. So this actually just came out yesterday. There was an eating disorder helpline that kind of ran out of money and decided that they were going to replace their human beings who were providing support for people with eating disorders with a chatbot. And for this particular user, they played with it and they said that every single thing that this chatbot suggested were things that actually would have led and encouraged further development of their eating disorder. So it recommended things like try to lose 1 to 2 kilos a week, try to control your calories. How about you count your calories? How about you monitor your carbs? Use a scale to measure the weight of your food. All of these things are actually behaviors that are very problematic for people with eating disorders. We have to, of course, along the way, if we're going to be thinking about increasing the diversity of our data, we have to then think about the issues around how we can work with highly sensitive data from underrepresented and marginalized groups safely. You know, it's really important that we incorporate this data so that the people are represented. You know, who's the data? But it's also critical that we protect the individuals whose data is captured. If somebody's going to disclose that they're trans or maybe intersex, that obviously being intersex has huge implications for your medical health. But that's also a highly sensitive variable. And so we need to be really careful that, you know, if our models are memorizing, that they're not actually memorizing the unique characteristics of a specific person that could put them at harm. And I would suggest that we're still at the beginning of this journey. You know, we have to be really careful and think deeply about how we're using this data and how we can use it in a way that really protects the individuals that are represented in that data. You know, it's who is in your data. There are people in this data. We can't just throw away their individual needs without understanding how we can protect them. So there's also been some discussion about using AI to support diversity and inclusion, with the idea that we can train models that are more objective and data-driven in order to assess people for hiring or performance review or promotion. I already kind of talked about one place where this might go wrong, but it is clear that if we, you know, that people are biased too, right? You know, we have unconscious biases and we have other cognitive biases that also impact our own interpretation of data or of people or in making these decisions. And so possibly, you know, we can use AI in a positive way in this context to actually encourage more data-driven and performance-based evaluation of people using variables other than, say, gender or race to do assessments. And AI, or I would say at least data science, because I think a lot of this is just basic data science and not AI, can be used to help monitor bias and employee engagement within organizations and give managers or leaders a tool for progress in the organization. So we can absolutely use technology, data science, and these tools and methods to collect data that might inform our decision-making around our organizations. And I wanted to make the point, and this, you know, has been very well studied for gender diversity, but there's clear evidence that in embracing diversity, even setting aside the AI context, gender diversity is correlated with both corporate profitability and value creation. And why is this? It's because having a more diverse group of people in the room actually leads to better innovation. There's more creativity, there's more consideration of different ways of looking at a problem and different solutions to a problem. And so diversity is good for companies, right? It's good for business. So it's good for AI, it's good for business. Why aren't we doing more of it? So what should we do? We need to ensure that the teams who are building AI systems are diverse, reflecting a range of perspectives and experiences. And I would challenge any business to really think about hiring for culture add rather than culture fit. Think about what a new person who's different from the people you already have brings to the table. Also, we need to be really careful about where we get that data from. Who's your data? What kind of data are we using to build and test our AI systems? Make sure it comes from a broad and representative sample where you've looked at it really critically to think about what's in there. We have to think about data governance, right? The privacy and the sensitivity issues with an eye towards coverage and quality as well. And importantly, we need to consider the context in which AI will be used and the potential for harm from these tools. When we have a tool, we need to monitor them for drift and have mechanisms to detect and report problems that we notice as users of these tools. And that kind of suggests a preference for human in the loop AI applications. And so I've been developing this model in the kind of clinical context where we really want to be thinking about augmenting humans rather than replacing human capabilities. And sometimes this might mean that we have kind of simpler, more constrained AI tools that solve more specific problems and surface information or surface predictions, provide predictions that can then be combined, by the human brain to make a decision rather than leaving the entire decision-making process to the machine. And this kind of model allows us to leverage the sort of the value of the AI while having a little bit of control in the process, because a human has access to a whole broader context than the machine often does. And it's not just who's in your data, but it's what variables have we captured in the data. We never have the whole picture of these people in the data, right? There are other external factors that we can't control for. In terms of the generative AI tools, I think this is also a case where we very clearly need a human in the loop. We have to make sure that the content makes sense in a particular context. And ultimately, it's the humans that have accountability for the texts that are produced and how they're used. And I like this little comic, but I think one kind of sweet spot is to think about using these tools to summarize text because it may be more effective than expanding text where we allow it to just sort of randomly fill in not randomly, but anyway, according to the model, fill in the language in the text. Okay, so what should we do? And I'm wrapping up now. We should approach AI with an ethical lens and ask questions about how it works, how it was trained, what data is in there, how it might impact users or the people for whom the decisions are being made. So, in the clinical context, that might be patients. Don't ask, can an AI do that? But rather, is this an appropriate use of automation? I think this is a little reframing that is worth putting into your kind of thinking as you're developing AI systems. So we're working towards responsible AI, right? Responsible AI is the new buzzword of the day. But what does that really mean? It means diversity and inclusion of people involved in creating the AI, diversity of the data, consideration of diverse users, and consideration of the different target audiences. We need to have transparency of how these models are built and where the data comes from. We probably need some interpretability. This is something that has sort of dropped down a little bit in attention in the last few months because we seem to be so excited about what these AIs, generative AI systems are producing now, and we've kind of forgotten that we used to talk about wanting to understand how it came to that output, right, or that decision. We also need to be talking about educating people or training people about all of these aspects of AI and the potential biases and limitations of the tools, and develop ethical frameworks. And so with that, I will say thank you and ask if anybody has any thoughts or discussion they would like to have.
All righty, thank you. Thanks, Karen. Very interesting and cool presentation, very insightful and very touching upon a lot of ethical issues of AI. So yes, there are a couple of questions, and let me just find the first set of questions, which was coming from Hind. So do you think that the training of the LLS on specialized knowledge and more contextual data, which is already going on, can address this problem about not about the issues that you've pointed out?
Yeah, so I definitely there's a lot of work that's shown that adding in a very specialized context for particular problems is one way of injecting in the right kind of language, if you will, into these models. So I mean, back when we had BERT, which was sort of one of the early precursors to what we're seeing now with the generative models, there was a whole slew of work that showed that, okay, if you wanted to work on biomedical applications, then you should infer your language model using PubMed, which is the primary repository of biomedical literature, or you should ingest a bunch of clinical text. And I think we're going to be seeing more and more of the sort of either building or expanding on the kind of foundation models that have been developed from huge swaths of general language, but then adding in the knowledge and not knowledge, because it's not really knowledge, but anyway, adding in the words and the data from the more specialized domain. And it's really critical to do that, because otherwise these systems just don't have the specialized language in order to be able to handle the specialized context.
Yep. Thank you. Thanks for your answer. Now we have another question from Limai, and it's more of a comment where, as you should avoid biases in data evaluation, the model without protected attribute, and I would like to suggest a use of a case using AI to detect evaluate biases in the human responses, such as hiring, promoting, insurance decisions, and analyzing outcomes and comparing them with performance if protected attributes are removed. So technically using AI to sort of, identify these biases and then use this ones as another perimeters to train the model. What is your comment on this? Would this be
Yeah.
a
So that was what I was trying to kind of get to with the comment about using AI to support diversity and inclusion initiatives. And that's exactly along those ways. I mean, so we can set systems up to for instance, have anonymous kind of, like double blind representation. And so imagine a promotion panel. And I think some companies have gone this route, where they're essentially given a data representation of a promotion applicant or a performance, somebody who's undergoing performance review, and a tool that then kind of gives you insights into where this person is in relation to their peers and other sorts of things, and basically models a trajectory, maybe make some predictions. All of this can be done using AI, and it removes some of the human biases from the equation. So yeah, I think there's absolutely a role for using AI to kind of I don't know, monitor human behavior as well, because they are they're not naturally biased, right? We're naturally biased, but the machines, if we can set them up in such a way that we control for the bias more effectively, then great.
Great, thanks for sharing this as well. We have two more questions, and after this, we'll move on to the next presenter. So Paul Cooper is asking about, let me summarize. I fully agree with the importance of having a diverse workforce to thereby give a good input to the long language models construction, but was thinking that having an external governance team with a diverse membership to provide oversight and enforcing testing of systems against the biases would be more practical and likely to succeed compared to the long-standing diversity employee composition problem. What is your thinking?
Okay, so this will require companies or organizations to be willing to open themselves up to external scrutiny, and I think that's part of the transparency. It's a model that can work. Then it comes down to what are the representation and the sort of perspectives of the people on the governance board. So I think that problem is maybe more easily addressed than the problem of making your whole entire organization more diverse. Of course, we
Correct.
have to start working towards that. But yeah, in the meantime, having, kind of a trusted board would be great. But companies then need to be willing to invest in that and to see that as a priority.
Good, thank you. And one more similar kind of question in the same line of thinking is from France, and it's asking, I was wondering if you could comment on the importance of diversity in data sets versus diversity in data scientists, and what you regard as a more pressing need if you need to choose one, and what is a more actionable approach from your perspective. Because you talked a little bit about that, about data scientists at the beginning, and then you move towards more of a to the data and actually the representation of data. So what is a more pressing issue according to you?
Look, they go together. I don't really think we can separate one from the other. So having a more diverse set of people in the room then will naturally lead to them asking questions about the data. So, I think we still don't understand enough, to be honest, about how changes in the data sets ultimately lead to shifting the overall bias in the models. So I can't answer that question. Great research question. But I think, we need to start by just having people who are asking the right questions about the data. And then perhaps it will, naturally lead to less biased data sets. It's a combination for sure.
Right. Okay. Thank you, Karen. I think thanks for your presentation again. I think it did steer a lot of discussion, and there's so many other comments that we didn't go through. But we'll
Thank you.
have to move on to the next speaker. So thank you again, Karen.